Hi, everyone, and welcome to today's Innovation Coffee. So we're lucky today to have an amazing guest with us. This is David Tischler that is joining me over here. Hi, David.
Hi, everybody.
Hello. Cool. It's really good to have you today. So I'm really excited about this chat that me and you will have today about a great project that you've been working on. But before diving into that project, let's walk a bit backwards and talk about your, who you are and I guess how you got to this point. So yeah, let's start with say a couple of words about yourself.
Yeah, absolutely. Well, thank you, Alessandro, for having me. It's really awesome to be hanging out on Innovation Coffee. And just to make sure that I have proof, I am coming to you live from Arizona. So it's early here, so coffee is totally applicable.
I've got my own as well.
Well, wait a minute. You're in Italy at the moment. I think that's afternoon. Is that acceptable there?
I'm having a nice latte at this point.
Okay. All right. Perfect. So I've got my coffee. I'm all ready. Yeah. So I'm David Tischler. As Alessandro said, I think it's probably best to kind of rewind a little bit and give a little backstory, a little bit of history. So I actually got started in my career working for a big hosting provider, big in the States here, GoDaddy. They don't necessarily have the best reputation, but that's a story for another day. No matter what, I spent about a decade there, and it always boggled my mind as I would walk through massive data centers full of servers, just burning electricity. And I would log on to these boxes. I was in a support role, and I would console these boxes, and I would find that they would sit there 90 to 95% idle throughout the day. They would certainly, have CPU spikes when they would run batch jobs, or in the web hosting world, somebody requests a website, it serves up the page, and then the CPU just sits there again waiting for the next request. So, after a couple of years of pondering this and watching the electricity meter just spin and spin and spin, I kind of thought there's got to be a better way. There's got to be something more efficient or better ways of going about this. And, this is definitely going to date me and reveal my age, but it's also about the time that smartphones came around, the first Android devices, the first iPhone devices. And I noticed generation after generation of these things get more and more powerful, and they were essentially becoming miniature computers. Some of even those first ones were more powerful than like my first machines way back when I was a kid. So started pondering it more and started to understand, okay, what is inside of a smartphone? It's a processor, it's memory, it's storage. That's the components that make up a computer, right? So these boards that are inside of a phone, could they have an Ethernet port on them? Could they become essentially a miniature server? And, here you go, fast forward another couple of years. Yeah, you've got devices like the Raspberry Pi. You've got boards from a company called 96 Boards that we're actually lucky enough to have join us as well on this call in a few minutes. And you start looking at these things, and they are, for all intents and purposes, miniature computers. So I started to explore that and launched a small company by the name of MiniNodes. And MiniNodes' entire focus was on small single board computers as servers. Now, obviously, there are workloads out there that absolutely require the most powerful Xeon server with the most cores and fastest cores you can buy. Totally get that use case for big data and other, cloud providers like AWS or Azure or whatever. But, I kind of thought maybe there's people out there that have more modest needs. And so I started racking these boards up, primarily Raspberry Pis and 96 Boards devices, and made them available for people to buy. And that actually does still still run to this day. There's still a small audience. It grows at a decent clip, but so there's an audience of customers out there looking for precisely that. But that work actually led me into something that I found to be even more interesting. And as part of the, I guess you could say, the engineering and learning more and more and more about the capabilities of these single board computers, I started doing a lot of like home hacking and kind of building interesting projects with them, at least interesting to me. An argument could be made as to whether they're interesting to other folks or not, but and then started to put together small demos and eventually started to see some community interest. And
I'll pause you for a second there.
Yeah, go ahead.
That's where we met, right? We met when you were actually working on mini nodes, and you were working on these small servers. I've always found it very interesting, the concept of a server based on Raspberry Pis, right? And I think that was when I found that first, it was super interesting to hear that actually someone was thinking of building servers that as you said, were more power efficient, obviously for more smaller workloads, but at the same time, really efficient for what they were meant to be doing, right?
Yeah, exactly.
And I think we've gone a long way, and you've done, I guess, a lot in your career in the last couple of years. One thing I was going to ask you, I was going to pause you a second on the I guess life journey, and I was going to ask you a question about our current situation, right? I mean, I was going to first give a disclaimer. I guess we're not medics, we're not doctors, we're not going to talk about COVID-19 or anything specific, but I'm keen to kind of examine the human side to the situation we're in today, right? So I was going to ask you, how has your life or your work life changed in the recent times?
Well, not too dramatically, and that actually is a little bit more of the continuation of the the work history story. I have always worked from home, so I haven't been super impacted, I guess you could say, as in like my daily routine has not really altered. I know there's a lot of people out there that used to go to an office and are now working from home, so they're having to adjust. I've always worked from home. When I fire up, I'll do a screen share in a minute, and I'll kind of show you my workspace. But actually, you know what? I can probably do it right now. Let's see here.
Because that is the other interesting thing, right? Is you've always worked from home, so for you it hasn't changed.
Yeah, other than having Alessandro, you've been privy, you've seen, other than having the kids running around here all day now because they can't go to school, so certainly have more interruptions, and it's harder to concentrate and focus for long blocks of hours. And I'm not a programmer. I'm not really one to sit here and actually write code. So, constant interruptions for someone who is a developer by trade, I could see that being really frustrating, where you need to focus and write and maintain a train of thought for, literally hours on end as you're building out your functions and your routines. So I'm fortunate, I guess, also in that respect, that interruptions don't affect the type of work that I'm doing too much. But, let me do a quick screen share and come over here to screen one. And then if that comes up, you'll be able to see, that's kind of my workspace. Normal desk.
I'm going to share your screen in a second. Yeah, there you go.
Yeah, pretty normal, pretty hacker friendly kind of desk. Now, I cleaned it before I took this picture. So in fairness, it's not always this clean. It's typically a little bit messier and a lot more wires and cabling and power supplies and the odds and ends. But that gives you a little sense of, that's kind of my my setup: laptop, monitor, and boards.
Yeah, that's cool. And I see, how many Raspberry Pis do you have in there?
In this picture, let me see. Yeah, I gotta do a quick count. 1, 2, 3, 4 Pis. 2, 3, 96 boards, devices. Actually, I guess one of these is a Balena Fin that kind of sort of counts as a Raspberry Pi device because that is a Pi compute module on a carrier board. I see there's an Orange Pi in that picture. I see a company represented there, Libre.computer. They build some really awesome open source hardware. Let me see. Out of frame, I think there's some Nano Pis. Yeah, you know, all kinds of odds and ends.
That's cool. I'm actually trying to solve a technical problem right now.
Uh-oh. Are we troubleshooting live?
Troubleshooting live. I've got so we've got the live stream on YouTube with a bunch of people watching, but we have a disabled chat, and I'm trying to figure out how to fix it. But it might be unfixable given that we're already live.
Well,
so
that's frustrating.
It's fine. Yeah, I mean, we'll try to fix it while we do this. But I'm sorry if you guys want to chat, you might be able to do it in a little bit. But it doesn't seem to be working right now.
Mm-hmm. All right. Well, if you guys want to take a look at that, I can actually
that's fine.
give you a little more. I'll continue on where this is, where the journey left off, I suppose, because there's one missing piece here, which is the work I was doing and the projects I was building, just because I kind of found them to be interesting and fun. Kind of like I say, it's I don't know that it's for everybody, but at least for the kinds of people that I was hanging out with, thought they were neat. So I started submitting to events for speaking engagements, kind of like you actually mentioned, Alessandro. That's how we met. So I had submitted a couple of talks to, I've been lucky enough to have been accepted for a couple of years now to ARM TechCon, Lenaro Connect, some ARM meetings, some local IoT meetings here, a couple of meetups up in Silicon Valley. Let me think, where else? And started to kind of get a feel for the public presentations, build a project, and then go and show it off, go and demo it in front of an audience. And I kind of like being on stage and kind of the whole project life cycle of create an idea, just come up with an idea out of thin air, build it, and then go show it to people. And typically those are prototypes, proof of concepts. They're not really, meant to be end products or not even really meant to be selling anything for that matter. It's just, to me, a lot of fun. So fast forward from there, after a couple of years of doing that and being lucky enough, like I say, to have been accepted to these speaking gigs and getting to know the ARM team, I came across an opportunity to do exactly that professionally for Balena. And Balena is an IoT fleet management platform. They're a system that allows you to run containers on IoT and edge devices. And so now here I am as a developer advocate for Balena. So I get to continue building cool projects and showing them off. It's honestly like the best job in the world. It's exactly doing what I like to do. So, it gives you a little bit of perspective there. They always say, do what you enjoy doing or do what you love. And it, certainly took me quite a few years, but I've finally found my niche, getting to do what I like to do. Alessandro.
That's awesome. Yeah, I'm back.
There you go.
And I've actually fixed the comments on YouTube, so we got
okay. Good. Perfect.
That's cool. And yeah, so you've moved to Balena, and I think one thing that we wanted to, the point of this call really was to discuss a really cool project that you've been involved in recently, right? And that is Rosetta at Home. And I'm going to ask you in a second what it is and, to tell us more about it. Mm-hmm. But, the interesting thing is that this is a real big community project. It's a research project. So again, we're not doctors. We're not, we're not involved in the research behind it, but there is a big community of developers actually developing and porting this software to run on different platforms. And in this case, you and Sahaj have done a lot of work around porting this software to run on ARM development platforms. Yep. And what's more interesting is that actually recently you've worked as part of your day job, I guess. You've got involved and you said, let me lean in and actually make it even simpler to get started with Balena for getting started with Rosetta at home. So I'll let you have, take the stage again and tell me more about what Rosetta at home is.
Well, so this is actually a good point to bring Sahaj in, actually, because we can now talk about what we saw, the problem we saw and how we went about solving it. So Sahaj, where are you? Let's get him into the stream. And there he is. All right. So I'll kick it off just real quickly with a little bit of what I had, kind of seen. Like I said, I'm very observant on Twitter, or I should say, I'm always watching the social media streams, and I see that people are building ventilators to fight the pandemic. People are building PPE and 3D printing visors and face shields for medical workers, for coronavirus patients, and all of those other things that people are doing to get involved. Well, I don't actually have any experience with any of that, but as you saw on my desk, I have a lot of compute power kind of sitting around. So I had kind of thought, okay, there are these efforts that I've seen, Folding at Home and Rosetta at Home, that do this protein folding that helps scientists and doctors run simulations. And again, I'm not a doctor. I don't know too much about it. But essentially, at least from what I gather, is that they were looking for ways to find proteins that attach to the spike that is on a COVID molecule. And if you can bind a protein to that spike, then it prevents it from entering a healthy cell. Again, that's all for the scientists and doctors to figure out. But no matter what, if I can just simply plug in some of my single board computers and let them run the calculations and simulations, then cool, that's a win. And I feel like I'm making an impact. So it turns out that those projects didn't actually work on my single board computers and ARM powered devices. So Sahaj, if you want to hop in here, I think you can probably speak a little bit better to the effort of getting the software running.
Yeah, I guess it was fairly easy with Rosetta at Home. Their code wasn't entirely open source. It was available under this special academic license, so we were luckily able to get our hands on it. Luckily for us, they weren't using something too special that's specifically coded at times. Sometimes you optimize and you end up with a piece of code that's written specifically for x86. And luckily that wasn't the case for us because they already had an old ARM target for Android and I think PowerPC as well. So it was basically just a matter of adding the proper ARM bits to their build system, and once that was in, there was just weeks and weeks of testing on our end to be done.
Sahaj, that's as I was saying before, it's amazing to see all this community coming together and enabling all these devices to actually run this really interesting research project, right? I see in the background you've got something on your left. What is that?
So that is something that I won from David on a bet. Here it is. And that is a very special piece of kit. It's not suddenly, it's a piece of hardware that AMD discontinued, but at one point AMD were making their ARM server chip. So that is an 8-core ARM64 server with 16 gigs of RAM on it. So, and that is crunching right now.
Cool. Let's bring back David. There you go. Right. So I think so we understand what Rosetta at Home is. Yeah. I think what's interesting now is the work that you've done to actually make it really easy, David, to to deploy on in mass on multiple types of devices. So should we get started? And we've got a lot of people online, so I think it's interesting if everybody can bring out their spare boards and actually, start going through the walkthrough and actually have people kind of join in and start crunching live with us. So David, take it away.
Awesome. All right. Thanks. Yeah, I think we have a good fundamental understanding now. After having covered it. So, like Sahaj has his server back there, which I was sad to lose in that bet, but I'm glad it went to a good home. The original work that we did to port the software made it available for the ARM boards. Now, you still had to know a little bit about, how Linux works, go install packages via apt-get. You had to make sure you had a 64-bit OS running on whatever type of device, et cetera, et cetera. So, there's a slight barrier to entry. Yes, it works, don't get me wrong, but you kind of need to have some administrative experience in Linux. So with that said, as I mentioned, now in my role at Balena, it's all about IoT fleet management and pushing containers to remote devices. So that underlying platform makes it really easy to just download an OS, flash it to an SD card, and pop it into a Pi or Jetson Nano or other type of device and get it online and joined up to your fleet. So we then essentially containerized the work that Sahaj and I had done and built a ready-made image that allows you to just simply download the SD card image, flash it, burn it to your device, to your card, power up, and you join the project. You join the Rosetta at Home project. So let me get my screen share back on. And let's see here. Share screen one. Okay, give that a moment and we should be back. All right, so if everybody can see this, we built out this landing page, this website. As you can see, it says help fight the COVID-19 pandemic with your laptop, Pi, or other spare computer. So this container that we built and the image that we built does run on x86 laptops. So if you have any spare old laptops or PCs laying around, this will totally work. But for today, we're sticking to a Raspberry Pi build. You can see actually at the start of this stream, we were at 2,267 devices that have joined the application. And I noticed the furthest north was Murmansk in northern Russia. And I think that Christchurch, New Zealand represents the furthest south. But it's pretty interesting to look at and watch the fleet grow. So over 2,000 people already have downloaded and joined the project. So let me scroll down a little bit and you can see, we'll talk a little bit about, what the project is, how it helps. And we've pretty much discussed that on this call already. And you can see some of the partners. The Rosetta project is run by the University of Washington. They've been very helpful in, like I say, helping us as we went down that journey of porting the code. ARM contributed, Packet has contributed, NeoCortex, one of their developers, helped verify and validate the results as well. And we've got Lenaro and 96 boards on here, of course, because as Sahaj just mentioned, he helped out with a lot of the porting. But let's get going. So if anybody has a Raspberry Pi 4, you can actually follow me along on this build. So the first thing I'm going to do is...
David, can I interrupt? Can I pause 1 second? I just wanted to add, basically, that you can see the drop down on the screen, right? If you can.
Yes, I apologize. Yep,
that's fine. I was just going to
pause there.
Mention that there is, as you know, you guys have done a great work, and you can easily deploy this on a lot of different boards. So yeah, basically click on that drop down and find your own board.
Exactly. And let me also see if I come over here, if I can switch to, nope, not that one. Let's see if my other camera's working.
Yep, you're live.
Okay, all right, perfect. So I have with me a Pi 4 and a Jetson Nano. Let me actually make a very quick note, though, that the Jetson Nano does require a couple of extra items, in that a Jetson Nano, if you can see, actually has an Ethernet port on it. I see it's a little blurry, I apologize. Come on, camera, focus. But a Jetson Nano does not have Wi-Fi. So if you're not going to be near your router, you actually need to use a USB Wi-Fi adapter. So I do have one of those. And you can power a Jetson Nano over its micro USB port, but you run into some power limitations. You really need a 5-volt 4-amp adapter, which connects to this barrel jack that is on here. In order to use that barrel jack, you need a tiny little jumper, and I can't remember the exact millimeter size of this jumper. It's a common size. I happen to have one laying around, but just make a note that if you're using a Nano, you can't power it over the micro USB port. You need to use the barrel jack. And I've got a little fan for it because it does tend to get pretty hot, and I don't want it to throttle down. But for this demo, we're going to use this Pi. So back on my screen share, Alessandro, if you can switch me back. Yep, that's perfect. I'm going to go back to Raspberry Pi 4. Now, this happens to be one of the larger Pi 4s. That's the 4 gigs of memory version. The more memory you have, the better when you're doing advanced scientific calculations and protein folding. So we'll get to it in a minute, but your 1 gig devices do not always have work available to pull from the queue, and I'll cover that in a second. But for now, I've selected Raspberry Pi 4. I am not near my router, so I'm going to provide my Wi-Fi credentials here. This is not storing your credentials like within the Balena system anywhere. It's actually just passing it through directly to the operating system that is about to be essentially created in the background. So now when I click this download Balena OS button, it's going to download a ready-made, and you can see that real quickly, the URL that flew by was api.balena. And the reason is it just passed those credentials over to a builder in the background, and downloading right now is the OS. All right, easy enough. So we've got the OS, and it was called Balena Cloud Rosetta at home ARM Raspberry Pi 4. Okay, next, need to flash it. So time for my SD card. I've got Balena Etcher already installed. Etcher allows you to flash images to an SD card or USB stick. It doesn't matter what the image is. It'll flash Ubuntu, it'll flash Raspbian, it'll flash OpenSUSE if that's your flavor. You know, it'll flash anything. But the point is, let me grab the file that just came down. Balena.
David, if you don't have Etcher installed, how long does it take more or less to install that?
I mean, that only takes a moment. It's a pretty quick download. Quick, right? You can get it from balena.io/Etcher. And I'm grabbing my SD card and plugging it into my laptop. Going in now. And we should see, hopefully, yep, there it goes. It automatically detected. Uh-oh, it went away. Hold on, did I not put it? Yep, there it goes. Okay. So now we've got the SD card in, and I hit flash. So I selected the image I downloaded, and away we go. So that's going to take a moment to flash. It's not a very large image, but in the meantime, yep, there we go, 2, 3, 4. So you can see the progress is actually pretty rapid. So yeah, I suppose
in the meantime, it might be interesting, David, I've got a question. So you were mentioning before that there are some requirements for the hardware. Could you be more specific in regards to what it is that is required to actually run this software?
Yeah, absolutely. So that's where I was starting to go. Thanks for the reminder. So you do need a 64-bit device. So a Raspberry Pi 3 or 4, an NVIDIA Jetson Nano, and then there's some other common ones like we saw in that drop-down menu. Actually, even a Google Coral board. Although we do not make use of the TPU that is on board, the Coral is a 64-bit ARM SoC produced by NXP. So anyways, point is it's got to be a 64-bit ARM device, and the absolute minimum amount of RAM is 1 gig. Now, as I started to talk about, the Rosetta project, these protein simulations, these calculations themselves are big. The vast majority of them need 2 gigs of memory to run. There are some that the university has submitted on occasion to the work queue that are smaller. So in that situation, if there are some proteins to be folded that happen to be smaller, those Raspberry Pi 3s with 1 gig of memory or Raspberry Pi 4s with 1 gig of memory will in fact grab them from the work queue, crunch them, and send them back for analysis. So the point is this: if you've got a 1 gig device, it may not pull work at all times. But if you leave it online, it will periodically check for work. If there's something in the queue, it'll grab it, crunch it, and then wait for more. So, I've seen some frustrated users that are saying, I just turned on my Pi 3 or my Pi 4, but it's not getting any tasks. It's not doing anything. And yes, I know, I'm aware. But, if the University of Washington is able to find some smaller proteins, they load them up and those devices will grab them. So if you're in that situation, the best thing is to just wait. And while talking about that, it looks like the flash is complete. So let me grab that SD card and put it into the Pi. Okay, SD card is in, got my power. And I see some blinking lights. Okay, so that's good. Blinking lights are always good. All right, now, while it's booting up, it's going to take a few minutes to power on and come online and essentially check in. While it is doing that, I'm now going to talk about how to take a look at if it's actually working. I can see the green LED on it is flashing. I don't know if that is going to show.
David, we have a question from the audience.
Yeah, go ahead.
So Michael is asking, he's got a green logo on the screen. He's asking what else he should be doing. I'm actually not sure.
I can answer it.
Oh, okay, yeah. You can get that. Yeah.
I know exactly what it's doing. So what it is doing is it sounds like it's still booting up, to be perfectly honest. It'll take a few minutes. And we might have to kill some time here, but I think we have till the top of the hour. But it will eventually, if you can still see on my screen, this is precisely where I'm going with this. It should reach a point where it shows a small terminal output about the jobs being run. So automatically enabled as part of this image is MDNS, which should hopefully provide you with a local URL on your LAN. Now, not all routers support this, but we have in the text here To view your Raspberry Pi 4's current activity, visit your Raspberry Pi 4's new host name, foldforcovid.local, in a web browser. So if you're on your laptop, you can plug in. Now, mine's not working yet. It's still coming online, but you can just simply go to http://foldforcovid.local. Now, again, I've noticed that some browsers, or I should say some routers, don't respect that. It's supposed to be a standard, and Sahaj, I don't know if you're still lurking back there or not. You may know more about that than I do, but I'm actually gonna just try to grab the device's IP address real quick from my router, just to make sure.
I've seen some people have it. So I get it working on, it's quite interesting. I get it working on my phone with .local, but actually on my computer, I can only get it working through .lan.
Interesting.
So I can only see, I can only access the LAN. But I see, I've seen that many other users are trying with local dash a number after it, right?
Exactly. You are exactly correct. So that's the thing. And my router, there it goes, actually, it just came on. So my router is somewhere, it's quasi-standard, and it will not respect foldforcovid.local most of the time, and it will append a number to it. So it's like foldforcovid.local hyphen some random number, and I can't quite figure out why. But anyways, the point is it should come up by foldforcovid.local. If not, grab your IP address from your router. And you can see now, so I guess, what did we kill? About 3 minutes of talk time? Here we go.
This is actually mine up and running now.
Oh, is that yours?
Yeah, so that's foldforcovid.lan.
Okay, go back to my screen share real quickly, and you'll be able to see. Yeah, turn your Inception. You're in
Inception over there.
Yeah, Inception. Now mine has just come online, and it's in download status. So it is grabbing jobs from the queue, and that'll take another couple of minutes, but it'll then essentially start crunching these. Now, jobs are big. These simulations are complex. You can see here that I'll go across the columns. Job number 1, they're all 5 of them are in the download status. They're from the Rosetta at Home project, and EST is 14 hours. So it's going to crunch these things for 14 hours. You got to leave the thing running. DL is deadline is 71 hours. That means if the job is not complete within 71 hours, it'll get submitted back to the queue for somebody else to grab it and work it. And then, of course, the task names. So the point is this. On this call, you literally just watched me download an image, flash it, power up a Pi, and it's in the beginning phases of doing its work. So the whole thing runs automatically. The work queue that it is grabbing from, like I say, is run by the University of Washington. And if you're using one of those smaller devices, if you don't grab tasks the way that mine has just now, just be patient as the scientists load up new simulations to be run. If they're small, your Pi will grab them. Let me switch my camera back now.
What's interesting is there is a different time that it is required to finish the crunching basically on all the different devices. So for example, right now you're running on a Raspberry Pi 4, right? Yeah,
that was a Pi 4.
And I'm also running, so mine is also running on a Pi 4, but I've got my jobs that are supposed to end in 7 hours. And actually I've got 4 of them running at once at the moment. So it's quite interesting. You have the 4 cores actually all crunching at the same time.
Exactly, yeah. Pi 4 is a quad-core device. Sahaj, that server that's behind him, that's an 8-core device, so he can run 8 of them in parallel. Memory seems to be, I shouldn't say seems to, is the biggest factor. So that's why I chose this 4 gig device. I'm able to run 4 simulations concurrently. I do have some smaller devices that have 4 cores or 8 cores, but if they only have 1 gig of memory, you'll see that it can only run 1 simulation, 1 calculation at a time. Or in this particular case, my jobs that it grabbed are 14 hours. You said yours were 7 hours. So again, they vary. Some of the proteins to be folded are larger, more complex than others. So, it's cool. It's an interesting and neat way to help out. Like I say, I don't have a 3D printer and I sure don't know how to build a ventilator, but at least I can do this.
Yeah. And I see some people in the audience. I shot JR has actually spotted something in the background, in my background. And I've got here a couple of boards, and I've got a Matrix Labs Matrix Creator board.
Yeah, awesome.
We've got a bunch of Matrix guys in the call. So
are they in here? Hey guys. Oh, I'm okay. I just flipped over to YouTube. I can see the chat now. Yeah. Hey, Samreen. Cool.
Right. Let's bring back Sahaj, and yeah, there you are. I'm keen to know what you've got crunching right now, actually.
Well, so this is the one device, and then let me just share screen for my crunch setup or use of it. Let's see. I think this one.
Let's see.
Can you?
Oh,
there it is. So it's a rat's nest, but this setup predates all the COVID thing that happened. So one fine day, I think it was late 2019, I had this idea. I have 20 or so boards just sitting there that aren't even 96 boards, so I don't really have like work from them, and those are my personal boards. So long time ago, before I joined Linaro, I used to review SBCs on YouTube, and I just had a large collection of boards. So I just wanted to put them over at Boink, which is where Rosetta works. Rosetta is hosted on the Boink server distribution network, grid network. And I just wanted to give the compute power away to science and for people to work. So I have 3 Pis here. So 2 of them are Pi 3, one of them is a Pi 2. I have a ROC 64. I have one of the NanoPi boards at the back. Don't remember which one. I have a Banana Pi 1, the original one. I have a Banana Pi N64. Then I have the original Crossbeam and a couple of boards that I have not connected because they don't really have newer distro builds, so not very comfortable connecting like kernel 3.14 to the network. Up top, I have the 2 bigger boards. This is the 96 boards RB3. Right now it's disconnected because again I'm doing some work. So the thing with using 96 boards, they are powerful boards, they have a lot of RAM, but I just have to work on them, so I cannot dedicate like a lot of time to crunch on them. So for example, the RB3 was working for about a few weeks, and then this week I had to make sure it finished all the tasks, and I had to remove it from there. And down below I have the Hikey 970, which is still crunching. So however many those boards are. Yeah, so, and this is like just a close-up shot of the AMD server that's behind me.
I've got a question.
Artistic shot.
Yeah.
So you were posting on Twitter. You're posting, I think once every couple of days. You're posting the number of boards crunching, and the number is rising really, really quickly. It's quite interesting to see how fast people are joining the fold. And I was wondering the number of credits that you post. So you post the number of boards that are joining, and then the number of credits that together we've kind of collected. What are those credits exactly? Do you have an idea of what the credits actually mean?
It's basically the amount of compute time that has been given to the project in terms of finished jobs, and that's around 200 to 300 gigaflops So not sure what the exact calculation is, a bit different, but on a rough point, 2 to 300 gigaflops should give you uh, 100 points or something like that.
Cool. That
So
sounds good.
we are currently at 20 million. So yeah.
Yeah, there is actually Rosetta at home is actually keeping up with a list of people or groups that are actually joining, and the interesting thing is that this community has come together, and not only you guys have done all the work on porting this stuff with the help of others that are not here, but it's a community effort really led by a bunch of people that really believed in this project, and then you also kind of made this group of people now crunching together, and it's really exciting to see the numbers go up and the credits going up. And we've got here I think this map is quite interesting. This is not all the boards crunching, because these are just the boards that are crunching through through Balena, but actually there's way more, like the hashes boards are probably not crunching or not on this number here.
Correct.
But it's crazy. It's crazy to see how many people are just starting to donate compute power to this effort. This is really cool, guys. I've got a couple of questions, and I'm also looking at the chat to see if there's any questions. I mean, feel free to ask questions in the chat. We'll ask them to these guys. Are amazing. And I've got a couple of questions on the Balena side. So it's quite cool. First of all, I'll let you, David, plug in the forum, because there is a really cool forum where people are posting a lot of questions, and I've got actually I can share here it is.
Yeah, my internet is a little slow at the moment, but here it comes.
Yeah, we've got the link there.
Yeah.
To see a lot of people.
For anyone watching or following along, I just took a glance at the YouTube comments as well. I see Michael Horn followed along and is successful. Awesome. Great job, Michael. But for anyone who ends up watching this later, if you have any questions about the process that we went through, the forums here, I triage most of the stuff. A couple of the other members of the team hop in as well. So I see here's one from our lead hardware hacker, Chris, has answered there. So, there's some things we can help with. Some of them are a little bit esoteric, but the point is I watch this all day long. So if you have any questions, you can drop them in here right into the forum. The other thing is it's all open source. It's on GitHub. You can submit bug reports. You can see here is one on a Jetson Nano, leverage the PWM fan. There's somebody who's got a startup hang, so we'll investigate that. Investigate ways to improve power management. So the point is you can put them in, and pull requests are welcome too. The fleet itself, because we've actually gone, so you can see there's 11 closed issues. There were some issues with some of the devices not grabbing more work after their original run. And I think we've got a fix for that. So we can do over-the-air updates to the whole fleet. Again, that's one of the key features of the Balena platform, is fleet management. Hopefully by the end of the week, we'll push out an update to address some of the things we found. We tested everything, but once you get up to 2,000 devices, you find a few edge cases. So we can address issues, drop them right into GitHub. We'll get them fixed and push out updates. So between the forums and GitHub, it's all done in the open. It's all transparent.
Yeah, and I was going to say that's the amazing thing here is that this is a live project that a lot of people are actually working on and contributing to. And as David was saying, there is a forum that you're watching directly, and there is also I think this is quite cool from an IoT perspective that we found bugs. I mean, I was telling you when we talked last time that there is a couple of things that I noticed, and it's quite cool that actually. There's going to be updates to the Balena image, and it's going to be pushed, as you said, over the air, and there's going to be basically everybody's going to have a new image that is running the latest software. On that topic, actually, I was going to ask you, what is it actually that we're flashing on the devices itself?
So again, in the spirit of open source, I mean, most everything that Balena does is open source. There are a few bits and pieces that are closed, like the code for the cloud dashboard and a couple other odds and ends, but the vast majority is all open source. So we build our own operating system called Balena OS. It's based on Yocto. Yocto is an open source embedded Linux distribution. And I know Sahaj is still lurking back there. He's got some experience with this as well. But the whole point of Yocto is minimal by design. Minimal by design is you only include the packages that you need in order to run whatever application or software or use case is that you're looking to achieve. So you're reducing your size of your OS to fit within smaller devices. You're reducing the number of applications or down all the way down to net zero applications that you do not need, because those are just potential security holes or vulnerabilities. So you're reducing your attack vector. And then in the case of over the air, where cellular connections or IoT devices may not have reliable connectivity or slow connectivity, you essentially want to shrink down as much as you can. So that's where Balena OS is derived from, is that Yocto project. And it's all about minimum footprint. But it's an open source Linux distribution.
Yeah, and that's really interesting. I mean, Yocto is at the basis of any real IoT deployment, right? Sahaj, are you running, what kind of operating system are you running on your boards right now?
Majority of it is Fedora, and then because that's just something I run regularly. A couple of boards that don't behave well with that, I have Ambient running on them.
Awesome. Cool. I'm going to pull in another friend actually that has got a bunch of. He's just told me he's got a bunch of boards running, actually live and crunching. So I'm going to pull him in. Give me 1 second. Hi, Raffaello.
Oh, hello. Good morning. How are you?
Good. Very good. So I wanted to give you or show you something before showing the boards. I've got.
Hold on. I have a t-shirt.
That's a surprise.
Well,
awesome.
Give me
what do you have crunching?
This is something cool. Okay, now I can speak. No, sorry. Oh, now I'm really serious.
What do you have crunching then?
I have a few stuff now. I was working with my Nano.
Wow.
Yes. But hold on. Okay.
Those sunglasses are just amazing.
Work. I have my robot here. I don't know if you see.
What is that thing?
Tell us what that is. Tell us what it is. The robot.
Okay, this is a long shot. One moment.
Maybe.
Okay. Is I don't know if you see now. Okay, my baby. Okay.
Yeah. Maybe this could be the topic for another call, but I think just give us.
Yes, exactly. This is a help the people for the to move stuff. Example for hospital. This is a good. This is a base, or I use the same technology for robotics to explore a place. In this case, it is an exploration robot. I use a Jetson Nano in this case, but I have other robot and other board. Today I was set up my environment with my Jetson Nano. This is a 3D printed cover, just to work a bit well. But just to show you something really silly, meanwhile you show the installation. I was, oh, hold on, okay, it's on, okay. I was ready for the fight. Yes, with toilet paper. No, I'm joking. I don't know if you see, but there is a nano here connected to the Ethernet. I don't know the reason why it doesn't work on Wi-Fi. But now it's connected.
It's got
You managed to follow along and set up how many boards?
I was the first nano just started. Now I want to set up my Raspberry, and I don't remember the Beagle board that works.
a Beagle board. No, I think those are 32-bit, if I remember.
Is enough. Is look should
I mean,
work.
you can join you can join TN Grid with that, but Rosetta requires 64-bit ARM.
Yeah, the Beagle, I think, is a 32-bit Texas.
Should be, yes. I think it's 32. Yeah. Yes.
Yeah, so unfortunately that one will not work
Okay.
for Rosetta, but that's all right.
Okay.
But wow, you did a great job. You added 3 devices just while we were chatting.
Exactly. But I miss another one. This was the previous board of my robot. He's here. He's in a safe place now. This is a Jetson TX2.
Oh man.
Yes. When I work on my robot, I have a lot of board. Hold on. One moment. Yes. Work with one hand is not easy.
Awesome.
He's bringing a lot of firepower to the table today.
Exactly.
Very cool.
I don't want to see the bill in the end of the month.
Oh, wait. I'll
Whoa.
bring that up. Put it up. Oh.
Get that thing crunching.
Yes, exactly. And I have this is an extra camera. Oh, okay. I was taking research about computer vision with this board and testing this camera. This is really nice, but this is another story. I will spend a lot of time otherwise.
No, but that's awesome. It's really cool to see like all the people joining in and actually like getting this stuff up and crunching. We've actually got a request from the audience here. Raffaello, I think you're wanted for. Can you see it? Can you read the comment?
No, I don't know. I don't want to read that. I'm afraid.
So JR is actually asking for you on a next chat.
Yeah, the next coffee, the next innovator coffee is going to be Raffaello going over his robot build.
Oh, okay.
Cool. So thank you so much. And
meanwhile, I will send you a picture later with my whole device ready.
Awesome.
Anyway, one is ready.
Cool. I mean, I'd love to see that.
Yeah.
Awesome. Thank you.
I have to.
Oh, sorry.
No, okay. I have to format another SD card now.
Yeah.
See you soon.
Bye.
Bye.
Bye, Raffaello. That's awesome. So,
Cool. So we're actually reaching the top of the hour.
Yeah.
And I mean, I'll bring Saj back in. It's really cool to have like you guys as a group working on this and actually really coming together as a community and making all this happen. And I mean, this is just one project that you guys are working on. And I think, as a group, there's a lot of other projects that are happening in the background and a lot of other stuff that are really exciting. I think one thing that I wanted to say actually is, should we put up the name of the Discord channel? Actually, do we have a link to it? You guys have
I can fetch that.
yeah.
if you can get me that'd be cool. So we can put it up because there is a lot of conversations happening in the Discord channel around projects that are happening right now and things, interesting things to watch. So it'd be cool if more people join that. So let me just grab this and I'll put it on. Let's see. There we go. So that's the Discord channel. we're actually getting close to reaching the other milestone with the Discord channel. So we'll have a nicer URL shortly, right?
Yeah, I think you need a certain number of people in there in order to get a custom URL. I know Robert's watching the stream. If he's able to comment into the YouTube thing, chat area.
But I think it's going to come soon.
I think so.
Yeah. Cool. Let's see what else. I mean, just I think, yeah, there's a conversation going about GPUs being used. I think if anybody, so as we said before, if anybody has got any other questions, I think join the best thing to do is either join the Discord channel, and there is conversations ongoing there about Crunch on ARM, or otherwise join the chat, what is it, David? Can you?
Oh, the forum. If you go
here they are.
Yeah.
Paulina.
Yeah. Any questions? Yep. Any questions? Just drop them in there, and either I or somebody on the team will get them answered.
Awesome. Well, it was really good to chat to you guys today. It was really exciting to see more people join the fold. And Sahaj, please keep on posting the updates. Every couple of days, I want to see the numbers rising fast, and hopefully that will happen soon. Thank you so much, and we should actually probably do a cheers with our coffees. Because it's, I mean, even though I should probably have a beer at this point. But.
Well, yeah, it's getting late enough for a beer for you. I'm still on coffee.
Cool. Thank you so much for joining, guys. Thank you, everyone, for joining, and see you next time.
All right. Bye, guys.
Bye.
See ya.
Bye.